Hi everyone. In this lesson we're going to summarize all of the different ways of graphing linear relations by hand. So here are a summary of the different kind of strategies that we have. Remember, you have to have two coordinates at least to draw a line, meaning you need to put 2 points on and then you draw the line between them. So we will refer to these each time we come up with a question, and I suggest you do the same when you're doing your own questions. Come back and look at this list and say, which one does this fit into? So example 1, select a method to graph each of the following. We're going to put 3 to 4 lines on each grid. There's no need to waste paper and put get a whole bunch of different graphs going when we only need one set of axes. First one, y equals 2/3 x minus 3. So looking at the list up here, which one does it fall into? Are we given a table of values? No. Let me get a pen here. We don't have a table of values. Y equals mx plus b. Yes, that's the form we have here. Y equals mx plus b. And here are the instructions. Place the y-intercept first. That's the b. So in that case, that's going to be our minus 3. And then the second step will be to count out the slope, which is m, as rise over run. So here's my m right there. So my rise will be a 2, and my run, so it's rise over run, rises and over a run of 3. So that's the method we're going to use for part A. So our axes are here, they're already labeled. The first thing I'm going to do is start with this y-intercept of -3. -3 gets a dot right there. That's the first step, place the y-intercept. The second step is to count out the slope as rise over run. So from here, really important, some students want to just count it out from the origin. No, counting out from the y-intercept, I'm going to rise 2. So I'm going to go 1, 2, rise 2, and then I'm going to run 3. 1, 2, 3. There's my dot. Okay, and remember up here it says you need at least 2 coordinates to draw a line, so I have 2 points on there, so now I'm going to draw a line in between them. And remember to extend your line, don't just draw it between the 2 points that you had. So there's my first line. Y equals, I'm going to color code them here, so this one is obviously in this blue color. And I'm just going to erase some of the other things I wrote up here so that when we do our next question we can kind of start fresh. Next one, we have m equals 2. That means we have the slope and we have a point. So this is also similar again to this method right here because we have the slope. So we'll graph the slope first, but we don't have the y-intercept, so we're not going to do that first. But we've got this point here. So we're going to put that point on. Even though this strategy up here says place the y-intercept first, we don't have a y-intercept, but really what it could say here is place any point first. So if you have a point, you put the point on first. In this case it's not b, and then we will count out the slope after that. So I'm going to place -3, -2. -3, -2 is going on in red. So this one I'm graphing in red. -3, -2, and then from there, so now I'm out, this step is exactly the same. From my point, I'm going to count out the slope. So I'm going to, my slope is 2, and that's really 2 over an invisible 1. So the first number is your rise, and your bottom number is your run. You never run 0, well, not right now. So we're going to rise 2 from here, from my point, -3, -2, I'm going to rise 2 and run 1. Put another dot there, and then draw the line. All right, so we've got a line here, and you try to always get it to cross both axes, and also to be extended a little bit here. And arrows on the end. I don't know if you've ever heard the phrase of being nickeled and dimed to death. That's kind of an old phrase about people who were being taxed on everything, and before they knew it, they had no money, even though their taxes were small. Here's a little bit here, here's a little bit there. I say that sometimes with doing little form things like this, not putting your arrows on, you lose half marks for that. You don't use a ruler, you lose a half mark for that. You don't label the scale, you lose half. That's being nickel and dimed to death. All of a sudden your test mark is getting smaller and smaller because of these little things. So please remember to use a ruler and draw the line properly. Don't just draw it in between your 2 points. That's definitely going to lose you marks. So there's our second line. Our third line is C. Remember the question said to put 3 or 4 lines on each grid, so we're going to put all 4 of these on this grid. What format is this? It's certainly not a table of values, but it looks like it might be, it's not a table of values, it looks like it might be y equals mx plus b, and it is. It's just that the b value here is actually a 0. So our y-intercept is 0. And remember, we do that first. We're going to place the y-intercept first. So I'm going to put my y-intercept right there. It's 0. I should reiterate here, table of values doesn't mean if you're just given a table of values. It means also if you're given an equation like we are and you don't know what to do, you can always sub in numbers. So for example, let's say I didn't realize that this was y equals mx plus b. I didn't know that was a 0. Let's erase that. And I looked at this equation and thought, I don't know how to graph this. I don't know which kind of strategy it is here. Well, what you can always do is sub in a value. So if I subbed in an x value of 1, so I'm going to create a table of values. Let me put it over here. Here's my x value, here's my y, negative 1/2 x. I could sub in an x value of 1 and sub that in. That gives me negative 1/2 times 1, which is negative 1/2. So that gives me the coordinate 1, negative 1/2. I could sub in a 2. Sub in a 2. Then I have to do negative 1/2 times 2. That's going to be y equals negative 1/2 times 2 is negative 1. That gives me the coordinate 2, negative 1. So you can always do a table of values, but it's always going to be longer. I'm going to erase that. But certainly you can do a table of values if you don't know how to graph at all. It will always work as long as you sub in correctly. But there's more chance for error because all of a sudden we're trying to calculate numbers. So let's go back to recognizing that this is y equals mx plus b. My b is a 0. There's my y-intercept at 0. Now my slope, so the next thing you do is count out the slope. My slope is negative 1/2. That means from my y-intercept, which was at the origin there, I'm going to rise negative 1. So that really what that means is I'm going to fall negative 1, and then I'm going to run 2 to the right, always to the right. So I'm going to fall 1 and run 2. So there we go. So this one I drew in purple. And I'm going to put arrows there. I do not want to be nickeled and dimed out of all my marks here. So if this question was asking for finding points of intersection, then it would be really important that we make sure the lines cross. I didn't make sure the red and the blue lines crossed, but if I did have a question about where do these lines cross each other, then I would make sure that I drew them longer so that they would cross, but we're not looking at that right now. So there's the purple one. Last one is x equals 5. So for this one, we look back up again to our summary, our bullet points here. X equals 5. That's a unique one. We're not going to do a table of values for it. It is not in y equals mx plus b form. It's in one of these two. It's either a horizontal line or a vertical line. So which does this match? X equals 5. It matches not horizontal line, it matches vertical lines. So this is going to be a vertical line. Vertical means up and down. And the equation is always x equals a number. So here's my equation, x equals a number, so I know it's vertical. I know it's a vertical line. And the way we graph them, really easy, whatever this number is, 5, I'm going to go on the x-axis, whatever this letter is, I'm going to go on the x-axis to 5, which is here. I'm going to put a dot there. And then I'm just going to draw a vertical line straight through that dot. And this was in green. And arrows there and there. Another way sometimes you might lose marks in a question like this is if, so what I did was I kind of color coded. I gave you a key, so if I was a teacher marking this, they would know which line is which. But if you just gave a bunch of lines and they weren't color coded, then you would have to write down the equation for each one. So I would have to go back and I would have to write down the equation for each one so that the teacher would know which one it is. Because if one of them's wrong, it makes it really hard to know if they're all wrong. Because if one's wrong, well, maybe your green one is supposed to be your blue one, and your blue one's wrong because it's supposed to be the red one. So it's really hard to figure out. So you need some kind of indication when you're putting multiple lines on one grid as to which line goes with which question. So there's our first one. Let's go down and take a look at the next group. Let me erase some of this stuff up here. E. We have the x-intercept is -5 and the y-intercept is 6. And you can probably just go ahead and graph that, but I'll just point out up here, graph using intercepts. So there's two ways to do that. If you were given the equation, we would have to figure out the intercepts, and you had a lesson on graphing with intercepts. But these, I don't even have to figure out the intercepts, they're already done. So I'm gonna go ahead and put them on. The x-intercept is -5, so I go to the x-axis to -5. You can see I'm using red for this one. And my y-intercept is 6, so I go up to a 6, and then I draw a line connecting the two dots. And arrows. Of course, remember you are always using a ruler to draw your line and putting arrows on the end of it. How about F? F is 2x minus 3y equals 12. Okay, what is that one going to be like? Let's go back up here. We're not going to use a table of values because we don't have it isolated. We don't have y isolated to use a table of values. Oops, that's an x. It is not in y equals mx plus b form. It's not in either of these forms, so it's not horizontal and it's not vertical. So let's hopefully the last one will help us. Graph using intercepts. So the equation is in a number with the x, a number with the y, and then a number, or this is the proper format here. Graph using intercepts. So do you remember how to graph with intercepts? That's what we're going to do here. I'm going to find the x-intercept first. To find the x-intercept, you let y equals 0. I'm going to take the equation and I'm going to put a 0 in for y. That gives me 2x, this is all 0, equals 12. Divide both sides by 2 and we get x equals 6. So there's my x-intercept. Now I'm going to find the y-intercept. I didn't leave myself much room here. Y-intercept. To find the y-intercept, we let x equal 0. It's always the opposite. Y-intercept, let x equal 0. X-intercept, let y equal 0. So 2 times 0 minus 3y equals 12. So this is just 0. I have -3y equals 12. If I divide both sides by -3, then y will be isolated. And I will have y equals -4. So there's my y-intercept, -4. And I'm going to draw a line through those dots. And get some arrows there. There we go. That one was in kind of a yellow, orangey yellow, oh, wrong color. Kind of a yellow color here. Last one on this page. G equals -3x squared plus 2. Okay, hopefully some of you already are saying, I know how to graph it, I'm going to go ahead and do it. Great. Go ahead and skip ahead to when my line is drawn then. The rest of us, let's go through our list here. Which one does it fit? Which method is it? It is y equals mx plus b. So we're going to place the y-intercept first, that's the b, and then we will count out the slope. So the first thing is the b value, that's the 2, that's b. So I'm going to put that on first. My y-intercept is a 2. Easy. The next thing that you take care of is the m. So my slope is -3. That's really -3 over an invisible 1. And since it's rise over run, that means I'm going to go up to my point here, my blue point. I'm going to drop 3 because it's negative. 1, 2, 3. And then I'm going to run 1, 1. And then I'm going to put a dot there, and this one, of course, will be in blue. So the only method we really didn't fully use was the first method, the table of values. But you have previous notes on how to do a table of values. You can review that at any time. So if you have an equation and you don't know how to graph it, you're putting your x values here, which we use -2, -1, 0, 1, and 2. Your equation goes here, say 2x plus 5, and then you're subbing into the x for all those numbers there to get your coordinates. It's the longer way to do it. It's better if you can find one of these other ones below it instead. These ones are faster. Okay, let's keep going here. Example 2. Since Jim is on the road a lot, he has a phone with internet access and a calling package, right? Most of you do. So it allows him to phone anywhere in North America. Jim paid $575 for his phone, and he pays $55 per month at the end of each month for his internet plan. That's a pretty expensive phone Jim's got. Let me just highlight the numbers. The numbers are always important. Paid $575 for the phone, and he pays $55. And I'm going to, every time, that word per, always that word per is important, so I'm going to include that as well. Use this information to create a table of values for 1 year. We have to create a table of values. Now, luckily, we've already been given the independent. When we graph it, that month is going to go down here. It's the independent. Whatever comes after the word per is usually your x. It's the equivalent, so let me write that there. It's usually the same as your x. And then the other one is your y. So our independent variable is per month, so how many months? If Jim uses the phone for 0 months, will he have any cost? He will. He will have that. If he only used the phone for a month, he will still have to have paid that $575, right? The phone wasn't free. That's a flat rate. That's your initial value. That's what he has to pay to start off, $575. So what if he has the phone for 1 month? Well, if he has the phone for 1 month, he's paying that if he just ended up keeping the phone for 1 month, he has that $575 plus he had to pay 1 month of the fees, which is $55. So that's $630. What about month 2? If he has a phone for 2 months, well, he had to pay his $575, and then he had to pay $55 2 times, so 55 and another 55. So really we're taking this number and we're adding another 55 on. Every month we're just going to add another 55 on, so that's 685. The 3rd month he has to pay another $55. That's going to be 740. The 4th month, another 55. So just I'm adding, clean that up, I'm adding 55. Adding another 55, and we're at 795. So let me clarify, because I know most of you have phones and you're thinking, what's going on here? At the end of the 1st month, he paid $630 if that was the end of his phone use and phone plan. If he only wanted the phone for that amount of time. If he only wanted the phone for 4 months, this would be his one-time fee. He wouldn't have paid $740 the month before it, and then the next month $795. No, this is just, he is basically paying when he returns his phone, and it will be based on how long he had the phone. He's not paying this each month. So if he keeps the phone for 5 months, he will pay a total amount of $575 plus $55 for each of the 5 months. So if he has it for 5 months, let me write that out. So he's going to pay $575. If he just keeps the phone for 5 months, he's going to owe $575 for the flat fee plus $55, but 5 times, 5 of them. So that total amount, if he has, is $850. If he doesn't trade it in or hand it in at the end of the 5th month and he has it for 6 months, then it's $905. Of course, it's more money. Every month he keeps the phone, he's paying another $55 all the time. So we're just going to keep putting $55 in, $960. The 8th month, this is a really expensive phone. The 9th month, $1,070. month 1,000. Wow, this, so we're not even up to a year yet, and we're already over $1,000, $1,180. So if he keeps the phone for 11 months, that's what he would have to pay for that 11 months. He doesn't pay each time every month. He pays at the end or at the beginning. If he says, I want to keep the phone for 11 months, this is my number here, I need a phone for 11 months. They do the calculations and they give him this number. And hopefully Jim is pretty good at bargaining and he can get that number down, because 11 months for a phone, it's a lot of money. So we've got our table of values. The next thing we need to do is plot the points and then join them with a line. Consider what you will label your axes and the scale that you will use. That's important. Look at these numbers. Well, the month numbers are easy. Let me scroll. Yeah, I can fit that in. The month numbers are pretty easy. The month numbers are only 0 to 11. So down here, let's go blue for this. This is my x-axis, but what it really represents is month or month number. So the month number goes here, and we only have to go up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no problem. We got 11 on there. And then the vertical axis, that's our y-axis. That would be the cost. So my cost, my lowest cost, this is the low number here, and here's my high number here. I need to get all of those numbers in, so I'm certainly not going to count by ones, and I'm not going to count by fives. How am I going to decide what to count by? Actually, what I can do, before we answer that question, I'm going to compress the graph. I'm going to put the little zigzag thing in here, which means I've squeezed the graph down, and I'm not even going to start at 0. I'm going to start at an even number though. I'm going to start at 500. So now my low number that I'm using is a 500, and then I have to get up to at least 1180. Now you could have just made this a 575 and counted by all these numbers because they're going up evenly, but we're going to do different things later in the year that these numbers aren't going to go up evenly. And if we get in the habit of just using all these numbers, for example, just putting 630 there, and then my next one is my next number, 685, and then my next number is the next number, 740, then that will not help us with all the other stuff we have to graph, because we can't just take these numbers and put them on the y-axis. They would work because we're doing a linear graph for this one, but it won't always work. So it is not wrong to just use these numbers here on the y-axis, as long as you know you're always adding the same. It's linear. You're always adding 55, 55, 55. It's always the same. But if it's not always the same, then you can't just label the y-axis like that. In this case, you could though, but I'm just going to show you a more general approach here. So I'm going to count by 50s. So my next, I'm going to skip the 550 and I'm going to go to 600. It makes it a little harder to graph when I have to put those numbers on, but it's good practice in setting up good axes. So 700, skip one, 800, and so on. So we got to make sure our high number is 1,180, so I've got to get up to 1,200. Now we put the points on, and this is where doing it the way I showed you, it makes it a little harder to graph because I don't have these exact numbers on my y-axis. So for example, 575, 0 and 575, that's going to be right about there. Remember, we're counting by 50, so the line is 550, so 575 should be kind of in the middle. My next one is 630 at 1 month, 630. Again, it's a little hard. I'm just doing the best. I know they have to line up in a line when I'm done. They might be a little off because of the axes, the scale that I picked here. 2 and 685, even harder, but I'm kind of keeping an eye on my other points and I know they have to line up. 3 and 740, that's just below 750. So I'm going to press pause now. I'm going to fill in all the rest, and I suggest you press pause and do the same. And also label with a word, this one was months, label the word that goes here on the y-axis. Okay, I've labeled my vertical axis as cost, got that from right here, my y value is cost, got all my points on, and now I'm going to get my ruler and draw a straight line. Now this case, unlike the other ones, I'm not putting a line down here, and you'll notice the way my axes were set up. They weren't set up as we did on the previous examples, which is with all four quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because a lot of word problems only ever use positive numbers. And this question about number of months and cell phone cost, those are all positive numbers. So we only use this, we put our x and y axis right here. There's our x, there's our y, and we're just graphing in here. So my line gets an arrow right here because he could have the phone longer than 11 months or 12 months, but he can't, there's no arrow down on this bottom end because at the y-intercept he can't have the phone any less than 0 months. So this time we do not put an arrow on this side, we just put an arrow up here. Find the equation of the line. That's our last piece. Find the equation of the line. You roll it up a little bit here. Okay, the equation of the line. We're going to start with that very important formula, y equals mx plus b. Well, let's start with the easiest part first, which is the y-intercept. What is the y-intercept, or the initial value? So we look at the y-axis, it says dot. I can't really tell. I'm just going to go up to my table to make sure I know what that value is. That's right here. Whoops, I didn't circle that very well. That's the 575. That was our low number. So let me change that. This is my y-intercept, and even in the word problem I knew that. Remember I wrote the flat rate right there? That's the amount that Jim pays at the very beginning. That's the initial value. So in for b down here, I can put y equals mx plus 575. Now in the final equation you must have a y and you must have an x, but the m needs to be replaced with a number. So how are we going to find the slope? Well, the slope is the amount that we're increasing by each time. So we talked previously about first differences, and the first differences are the numbers that I'm showing you right here. Whoops. The first differences are the number that we're every time we increase by. So we increase by 55 every time. And also you can tell the slope that is 55 by looking at the question. It says he pays 55 per month. So that's telling me for every 1 month it's going to increase by 55. It's in an increase. So my slope is a 55. And still, if that's you're still not understanding, you don't think you can get that on your own, then all you need to do is take 2 points on your graph and either count out the rise over run or you use the formula. Well, let's do it. Let's use the formula. M equals y2 minus y1 over x2 minus x1. So we pick any 2 points, and we're going to go up to our table to do that. Let's pick this point and any other point you like. Well, I already have that one circled. Let's use these two. This is my x1, this is my y1, this is an x2, and this is a y2. So subbing in, you get 740 minus 575 over x2 is 3, x1 is 0. So what is 740 minus 575? Is 165 over 3, and 165, surprise, surprise, is 55. So that's another way you can get your slope. If it was hard to understand from the question, if you didn't really recognize that you were increasing by 55 each time, that was your common increase, then we would use the formula. And the formula is really quite foolproof. The reason I could tell the 55 right from the question, if you remember back to our first differences, these numbers were all increasing by 1. We're adding 1 each time. If I weren't increasing by 1, then this number would not be my slope. So there's a couple of different things to think of. So it's a bit of a more complicated way to get the slope, but the slope formula here will always work. So now we have the slope. 55x plus 575. Oh, and that goes down here under the question. Find the equation of the line. Equation of the line, let me just change it. Sometimes our questions use the letters that were in the problem as opposed to y and x. So y, this was y right here, cost. So maybe you could write this equation, or you might see answers like this. Cost equals 55, and instead of x, what did we use for x, remember? We used the month number, so maybe an m here for month plus 575. That's the equation of that line, and that is the end of this lesson.